Yeah. Hi, hello, dear students. Once again, welcome to my class on structure of atom. In this video, as I told earlier, I would like to explain the photoelectric effect on a particular electron-like species, how it behaves in the atom. For that, we are going to discuss about this electromagnetic radiation behavior and the discrete small packets of energy which were discussed in Planck's quantum theory, which is assumed as a photon in this concept of Einstein's photoelectric effect. The concept is photoelectric effect. Photoelectric effect. So in this, we would like to know about what is exactly the electromagnetic radiation. What is electromagnetic radiation? Is nothing but particle nature of light will be discussed in this one. That means as electromagnetic radiation is a discontinuous waveform explained in this Max Planck quantum theory, which is proved as a photon in this concept. So whenever we used to call a photon in this concept, photon is nothing but a light particle, and which is a small packet of energy, which is taken as quantum in quantum theory, Max Planck quantum theory. The small packet of energy is said to be photon, and this energy, as per this Max Planck quantum theory, is said to be directly proportional to the frequency of this radiation, which was given as E is equals to h nu, and where h we called as Max Planck Planck's constant. We have given the constant value also for this one. In this photoelectric effect, we would like to discuss about the concept related to how this uh, particle behavior of light will be understood by considering a specific metallic surfaces like alkali metals. As you all know, what are exactly the alkali metals you can consider in this one is nothing but there are few alkali metals are there. In these few alkali metals, we can consider potassium, rubidium, cesium. Potassium, rubidium, cesium. So any one of these alkali metals, if you consider, these alkali metals are said to show this photoelectric behavior, photoelectric effect, and indicates that these metals are surfaces are very much sensitive, and they consisting of electrons. That electrons will come out of the metal surface if a suitable frequency or of energy of light is said to be fallen on their surfaces. This is what simple concept, and these alkali metals are said to be releasing electrons. Electrons will be ejected from their metal surfaces. Is actually a simple concept called as photoelectric effect, but it has a mathematical meaning is there, and numerical also will come from this photoelectric effect. That how mathematical formula which is given by photoelectric effect given by Einstein, we will check it. Okay, let us see. So in this Einstein's photoelectric effect, the definition, when you want to know, the definition is nothing but ejection, ejection of electrons, ejection of electrons takes place, ejection of electrons takes place from the metal surface, when a suitable frequency, of the light falls on the surface, What do you mean by this one is nothing but electrons will come out of the metal surfaces when a suitable frequency of light is said to be falls on their surfaces, or else what will happens, these electrons remains attached with that metal surface only, but that light will shine when the electrons are said to be trying to move from the metal surface. For example, if I take red color light and yellow color radiation, then in this one, as per our whatever the data analysis, as per the researches books and all NCRT, we can take this is the arrangement, that is the order in which it has 4.3 to 4.6 into 10 to the power of 14 hertz is the red color frequency range is there, whereas yellow color light if you take, it is 5.1 to 5.2 into 10 power 14 hertz is the frequency is there for these two radiations. So what do you mean by this one is nothing but the red light of this brightness may shine on the piece of a particular metal like potassium. That means if you take potassium has got the frequency, a suitable frequency, that threshold frequency we can call for that one is 5.0 into 10 to the power of 14 hertz. That means the minimum frequency which is required for the surface on the metal surface like potassium is 5.0 into 10 to the power of 14 hertz. So when you compare these two frequencies of radiations, definitely obviously this yellow color radiation is said to be ejecting the electrons from the potassium surface, as this is suitable frequency of light which ejects the electrons from potassium surface. That means yellow color radiation will definitely exhibit a photoelectric effect. That means potassium metal shows photoelectric effect when yellow radiation is falling on the surface. Okay, this is what we can say the example of a particular frequency of light. Next, let us see its mathematical concept. It means a formula based discussion on the photoelectric effect given by Einstein. Okay, we will move on to this concept in which electrons are ejected, which is directly proportional to the intensity of the light which we have focused on the surface of metal. So what we can understand here is nothing but the whatever the light, incident light is there, the light, incident light is must said to be possessed with a frequency, and that light is said to be associated with some energy. So if the light is falls on the metal surface, electrons when they will come out of the metal surface is nothing but if this light frequency is matches with the threshold frequency of the metals, then electrons will come out. Okay, in this phenomena what we can understand is nothing but electrons should come out of the surface of metal by two ways. That means the energy given to this electron is said to be utilized in two forms. One form is nothing but the kinetic energy. The utilization of the energy which is given by the electron from the surface of the metal will be in the form of kinetic energy. The rest part we will call it as to do some work. So that we will call it as W. So what is this energy? Energy is h nu, and this is kinetic energy. The W will call it as work function. What is W? W is called as work function, which can be written as h nu naught. So minimum energy which is required for any of the electron to come out of metal surface is the work function of this is characteristic property of each and every metal in this alkali metals concept, photoelectric effect. So this H nu naught is also one form of energy. So what is H nu? The energy which is previously given to the electron on the metal surface, and this is Ke, this is H nu naught. This is what we call it as the mathematical representation of the photoelectric effect, in which we would like to find kinetic energy. Also it is possible, that is kinetic energy is equals to H into nu minus nu naught. We have taken H as a common value here in this, and whereas this nu and nu naught not given, lambda value is given the problem, then we can extend this one as kinetic energy is equals to H into nu is C by lambda. So you can write this is C by lambda, this is C by lambda naught. You will call it as the threshold wavelength, and you can take C as a common value, then Hc by lambda into 1 by lambda minus 1 by lambda naught. So kinetic energy is equals to Hc by lambda, Hc into lambda 1 by lambda minus 1 by lambda naught. After that, if you take LCM, then it will become Hc into lambda naught minus lambda by lambda naught. So that is the another important mathematical formula to find the kinetic energy as per the photoelectric effect. So that means electron should come out of the metal surface, means it has to go against the attractive force by the nucleus, and for that all this energy will be supplied from outside in the form of electromagnetic radiation. That's all. This is what we will call it as photoelectric effect. I hope you understand. Have a nice day.